Hello everyone, myself Chethan GA, MSc in Computer Science at Manasa Gangotri, University of Mysore. Today we will discuss about the topics of machine learning, that is support vector machine classifier or SVM classifier, linearly separable cases, non-linearly separable cases, and finally kernel functions. What is meant by a support vector machine? Support vector machine or SVM is a supervised machine learning algorithm which can be used for both classification and regression challenges. However, it is mostly used in classification problems. In the SVM algorithm, we plot each data item as a point in n-dimensional space where n is the number of features you have, with the value of each feature being the value of a particular coordinate. Then we perform classification by finding the hyperplane that differentiates the two classes very well. Look at the below image. Support vectors are simply the coordinates of individual observation. The SVM classifier is a frontier which best segregates the two classes, hyperplane or line. Support vector machine algorithm. Support vector machine or SVM is one of the most popular supervised learning algorithms, which is used for classification as well as regression problems. However, primarily it is used for classification problems in machine learning. The goal of the SVM algorithm is to create the best line or decision boundary that can segregate n-dimensional space into classes so that we can easily put the new data point in the correct category in the future. This best decision boundary is called hyperplane. SVM chooses the extreme points or vectors that help in creating the hyperplane. These extreme cases are called as support vectors, and hence algorithm is termed as support vector machine. Consider the below diagram in which there are two different categories that are classified using a decision boundary or hyperplane. How does SVM algorithm work? SVM is a supervised machine learning algorithm which can be used for classification or regression problems. It uses a technique called the kernel trick to transform your data, and then based on this transformation, it finds an optimal boundary between the possible outputs. Why do we use SVM algorithm? SVM or support vector machine is a linear model for classification and regression problems. It can solve linear and nonlinear problems and work well for many practical problems. The idea of SVM is simple. The algorithm creates a line or a hyperplane which separates the data into classes. In these figures, the support vectors are separated by the hyperplane. Example for support vector machine. SVM can be understood with the example that we have used in KNN classifier. Suppose we see a strange cat that also have some features of dogs. So if we want a model that can accurately identify whether it is a cat or dog, so such a model can be created by using the SVM algorithm. We will first train our model with lots of images of cats and dogs so that it can learn about the different features of cats and dogs, and then we test it with this strange creature. So as support vector creates a decision boundary between these two data, cat and dog, and choose extreme cases which support vectors, it will see the extreme case of cat and dog. On the basis of support vectors, it will classify it as a cat. Consider the below diagram. Let's see some of the applications of support vector machine. Image-based analysis and classification task, geospatial, data-based application, text-based applications, computational biology, security-based applications, breast cancer diagnosis. Note: the applications of support vector machine are not limited to these categories. It is a classification as well as a regression algorithm, and the users are endless. Real-time applications of SVM: face detection, text and hypertext categorization, classification of images, bioinformatics, protein fold and remote homology detection, handwritten recognition, generalized predictive control. Let's see some of the advantages of support vector machine. Support vector machine are very good when we have no idea about the data. Works well with even unstructured and semi-structured data like text, images and trees. The kernel trick is the real strength of SVM. With an appropriate kernel function, we can solve any complex problem. Unlike in neural networks, SVM is not solved for local optima. It scales relatively well to high-dimensional data. SVM models have generalization in practice. The risk of overfitting is less in SVM. SVM is always compared with ANN. When compared to ANN model, SVM gives better results. Let's see some of the disadvantages of support vector machine. Choosing a good kernel function is not so easy. Long training time for large data sets. Difficult to understand and interpret the final model, variable weight and individual impact. Since the final model is not so easy to see, we cannot do small calibrations to the model, hence it's tough to incorporate our business logic. The SVM hyperparameters are cost, C and gamma. It is not that easy to fine-tune these hyperparameters. It is hard to visualize their impact. Types of SVM: linear SVM and nonlinear SVM. Linear SVM. Linear SVM is used for data that are linearly separable, that is, for a data set that can be categorized into two categories by utilizing a single straight line. Such data points are termed as linearly separable data, and the classifier is described as a linearly separable vector machine classifier. Nonlinear SVM. Nonlinear SVM is used for data that are nonlinearly separable data, that is, a straight line cannot be used to classify the data set. For this, we use something known as kernel trick that sets data points in a higher dimension where they can separated using planes or other mathematical functions. Such data points are termed as nonlinear data, and the classifier used in termed as a nonlinear SVM classifier. Linear support vector machine. The working of SVM algorithm can be understood by using an example. Suppose we have a dataset that has two tags, green and blue, and the dataset has two features, x1 and x2. We want a classifier that can classify the pair x1, x2 of coordinates in either green or blue. Consider the below image. So as it is in 2D space, by just using a straight line, we can easily separate these two classes. But there can be multiple lines that can separate these classes. Consider the below image. Hence, the SVM algorithm helps to find the best line or decision boundary. This best boundary or region is called as hyperplane. SVM algorithm finds the closest point of the lines from both the classes. These points are called support vectors. The distance between the vectors and the hyperplane is called as margin. And the goal of SVM is to maximize this margin. The hyperplane with maximum margin is called as optimal hyperplane. This figure shows all the points. Nonlinear support vector machine. If data is linearly arranged, then we can separate it by using a straight line. But for non-linear data, we cannot draw a single straight line. Consider the below image. So to separate these data points, we need to add one more dimension. For linear data, we have use two dimensions x and y. So for nonlinear data, we will add a third dimension z. It can be calculated as z is equal to x2 plus y2. By adding the third dimension, the sample space will become as below image. So now SVM will divide the data sets into classes in the following way. Consider the below image. Since we are in 3D space, hence it is looking like a plane parallel to the x-axis. If we convert it in 2D space with z is equal to 1, then it will become as. Hence, we get a circumference of radius 1 in case of nonlinear data. Let's move to the last topic of our presentation, that is kernel functions. What are kernel functions? Why they are used? Kernel is used due to set of mathematical functions used in support vector machine. Provides a window to manipulate the data. So finally, the kernel function generally transforms the training set of data so that a nonlinear decision surface is able to transform to a linear equations in a higher number of dimension spaces. What is the kernel of a function? For any function where and are any sets, the kernel, also called as null space, is defined by. So the kernel gives the elements from the original set that are mapped to 0 by the function. What is kernel function in machine learning? In machine learning, a kernel is usually used to refer as a kernel trick, a method of using linear classifier to solve a nonlinear problem. The kernel function is what is applied on each data instance to map the original nonlinear observations into a higher dimensional space in which they become separable. Kernel functions. Before we can jump into the kernels, we need to understand what is a support vector machine. Support vector machine, or SVM, are supervised learning models with associated learning algorithm that analyze data for classification. Classification means knowing what belongs to what. For example, apple belongs to the class of fruits, while dog belongs to the class of animals. See in the figure. In these figures, vertebrates and invertebrates are belongs to the class of animals, in which fish and mammal belongs to the class of vertebrates, as well as crustacean and insect belongs to the class of invertebrates. How does kernel works? To better understand how does kernel works in mathematical illustration, the mathematical definition for the kernel function is k of x comma y is equal to f of x comma f of y. Here k is the kernel function, x comma y are the dimensional inputs, f is a map from n dimensional to m dimension space. X and y denotes the dot product. Usually m is much larger than n. Normally calculating f of x comma f of y requires us to calculate f of x and f of y first, and then do the dot product. These two computation steps can be quite expensive as they involve manipulations in m dimensional space, where m can be a larger number. But after all the trouble of going to the high dimensional space, the result of the dot product is really a scalar. We come back to one dimensional space again. Now the question we have is, do we really need to go through all the trouble to get this one number? Do we really have to go the m dimensional space? The answer is simply no, if you find the clever kernel. Let's take an illustration example for the kernel function. Let us say that we have 2 points, x is equal to 2, 3 and 4 and y is equal to 3, 4 and 5. Let us apply the kernel function, and the mathematical steps are very easier to understand. Same results, but this calculation is so much easier. That's about it for kernels. Most simplified steps in kernel function. Another example for kernel function. Which kernel is best for SVM? So the rule of thumb is use linear SVMs or logistic regression for linear problems, and for non-linear kernels such as radial basis function kernel for non-linear problems. Thank you.